How's it going, ladies and gentlemen? Welcome back to my channel. Hopefully you had a very good Chinese New Year and spent a really good time with your friends and families. So in this video, I'm going to talk about the difference between the new grads and also the experienced software engineers. Previously, I made a video talking about the traps in coding. When I filmed that video, I've been working at Binance for around 3 to 4 months. So that is a really important video talking about the difference between the students and the full-time software engineers. If you're a student, I would highly recommend you to watch that video, since that can definitely make you a difference, since that can tell you how and what to do in college and to make yourself different. And therefore, when you're going to find jobs, when you are going to become a full-time software engineer, that can lead you a very significant step and make you stand out. Alright, in this video, I will compare the difference between the new grads and the more experienced software engineers. I have to say, I've been just working like around 8 months. I'm still like in between the new grads and more experienced level engineers. But here, I would just to share what I've found and what I summarized so far with you. And hopefully this video can benefit both us. Probably before we get started, we have to understand what's the most different thing between the new grads and experienced level engineers. It's not just about the working time. The reason behind it is because for those individual projects, basically you don't have to be readable, to be scalable, since the only reader is you yourself. For example, when you're creating a website, right? Who will read your code? Nobody. You yourself only. However, when you are going to a company, actually you are working with a group of people, with a group of engineers. And therefore, in those scenarios, you have to make sure other people can also understand your code as well. Meanwhile, you should also make your code to be maintainable, since when you are going to write codes, for example, a personal project, it's not really necessary to maintainable. You don't have to set a tons of clusters and don't have to set great pipelines to make sure everything is automatic, since you can just do it by yourself. However, when you go to a company, it's a totally different story. You have to make everything, every step to be really good and to be really autonomous, and therefore that can make your team progress really fast. Alright, so let's get started. The first thing is about tests. So if you don't know what test is, test basically has two different categories. The first is unit test and second is integration test. For unit test, it's more like you test for a particular function individually. The purpose for that is to just make sure when other people change your function or do some refactor on it, the main functionality, the features are the same. However, for the integration test is from a macro point of view to just test the whole flow to make sure that your software, your program is working. There is no missing bugs or there. Probably the question here is why test is so important. Test is really important in industrial level, since, for example, whenever you write some code, you don't know whether your code, the parts that you refactored or amended, would affect other people's code or not. However, you just can't, test to try all kind of stuff, right? Therefore, tests here are really like a guardian to tell you where is the mistake and to let you know in advance. And therefore, you can just change on your local computer and to make it readable and to make it fully functionable before you upload it. Here I would like to give another suggestion about testing. So probably some of my teammates, they will highly recommend, like whenever you have a function, you wrote a new function, you have to write a unit test for that. So here is a true story happened on me. So one time when I was writing a program, I just finished the unit test immediately. However, 1 week later, the logic for the program has changed and I have no choice but to rewrite the unit test. And just 1 week later, the logic changed again, and therefore I just rewrote the unit test for 3 times. So that is quite unnecessary. Therefore, my suggestion here is you should have unit test unless your logic, your main logic has been confirmed. The second part is about architecture. Architecture here stands for the architecture for the folders, for the layers. It's not how you structure your code basically. So when you're back to school, especially for example, when you're writing those lead codes, right? Who care about those architectures since you just have one file? There's no need to worry about architecture at all. However, when your project becomes bigger and bigger, architecture becomes an inevitable topic that you have to care about. Architecture basically have a lot of models. If you search online, you can find tons of architecture. However, the most important thing for architecture is you have to make your code, your project, your repo really structured well. So first you need to care about whether it is easy to test or not, especially for unit tests, since if you just structure it randomly, it's really hard for you to put a unit test. And second is about the plug and in this kind of purpose. So if you don't know what plug and in, you should know like your laptop. There is USB plugin, there is Type-C plugin. So it's the same thing. When your project becomes bigger and bigger, there will be more and more services that are integrated in your project. And therefore, you have to understand like how to integrate those kind of services into your project. It's not very clean and readable if you just put it here and there. When your project becomes large enough, that will be just a big mess. So here is an example. Another team, their project is becoming bigger and bigger, and therefore they just refactor the code again and again. So basically they're not have a very good structure, have a very good architecture, but they just want to repeat this kind of tedious procedures. However, for our team, so one time we decided like we have to make it really standard, and we just don't want to change architecture in the future anymore. And therefore we invested a lot of time and manpower into this part and make our architecture really good. So for a long time, until now, we haven't changed our architecture anymore. So this is really like a short-term profit against the long-term profit. Next thing is about speed. Speed is somehow encountered with us when we're doing lead code, right? Since there is time out. However, when you are writing your personal project, would you really care about like what's the time complexity for a function or how long does it take? You won't care about it, since as long as it works, that's it. That's the main purpose for personal project, okay? However, when we are writing a industrial level project, there are a lot of services here. If your service is like 1 millisecond lag and his service is like 2 milliseconds lag, and if you added all this kind of thing together, that would be a huge lag. A project is not determined by an individual service, but the entire system. And therefore, in each projects, in each part's services, you have to make it as efficient as possible. So here's an example happened on me. Previously, when I was working in another team, I inserted a lot of not really necessary, logs there. However, those logs are really time-consuming and unpredictable, since those logs are basically connected to another service, while that service is not that stable. And therefore sometimes, yeah, it's fast, but sometimes it's really slow. And this really caused a lot of trouble for that repo, for that service. And one day we just find out, and the bottleneck was just because of my logging system. And therefore I had just deleted everything and try to manage that part into some other services in order to make this service really fast. The last part is naming. Previously, I just don't believe it. However, after working longer and longer, I found that naming is basically the most difficult part in software engineering. If you're a student, probably you still won't believe me. So for example, like a phone here, I can name it as a phone, as a black phone, as iPhone, as whatever phone, etc. It doesn't matter since it's still working. However, yeah, functionality is the same. However, if there are a lot of people are working on this project, a proper naming will really benefit the rest of the people. Here's the case. Sometimes if other teammates don't understand what your naming is, what this variable stands for, their parts will be really suffer from yours, since they just don't know what's your logic and how to use your function or other services or APIs. And therefore in those scenarios, they will always ping you like, hey Nian, what's going on here? How to use this? And if you are really clean and maintainable, then basically they won't reach out to you. They just will know automatically how to use that. So that's the beauty here. When I was at college, I would like to name a lot of variables, for example, temp, temporary, or info, information, or other kind of stuff like item, thing, project. Those are terrible names. If I look back to my codes, I will just give myself a big F for my previous project. However, the good thing is when you are writing more and more codes, especially have some really experienced people to guide you and to let you know what are the names you should avoid, it's really benefit to you, basically. And you can learn and grow really fast. So that's the beauty for industry and for industrial level engineering. Alright, I think this is enough for this video. If you have any questions or comments, please feel free to leave them below. Also, if you have any other interesting topics in your mind, also please leave them below so I can take a look and make another video for you. Thanks for watching. Have a great weekend.